Thank you so much, Anna, for inviting me. I'm excited to be here to talk about AI agent evaluations. So my name is Amira Best. I'm a Women Takemakers Ambassador, and I have the standard disclaimer that the views expressed here are my own and do not represent my employer. So about me, I'm a cross-industry AI professional. I have a doctorate in computer science and over 15 years of experience in academia, government and industry across industries. So I worked in biotech, pharma, manufacturing, and financial domains. So let's start to talk about evaluations, or evals for short. So here's the outline. We're going to talk about what are evals, what are the types of evals, offline versus online evals, and then the importance of the creation of the golden data set, how we can use LLM judges and how to align them, rubrics and failure mode analysis, and finally the production flywheel. So let's get straight to it. So at their core, evals are short structured methods for measuring how well an AI agent performs on a defined task or set of tasks. So you can think of evals as the testing framework for your AI. It's just like software engineers write unit tests or to verify that code does what it's supposed to do. We write evals to verify that an AI system behaves the way that we intend, at the quality we require, and across the range of inputs that we care about. So evals span a spectrum from simple automated checks where you can verify an output matches an expected format, to complex assessments such as with the nuanced reasoning on quality. They share structure. They have a defined input, some success criteria, and a method for measuring it. Evals do three jobs. First, the evals guide key decisions. So whether we're choosing different model versions or we're comparing different prompt strategies or system architecture changes, the evals will provide an empirical basis for these decisions rather than relying on anecdotal evidence. Second, the evals serve as a safety net. So a robust evaluation suite can catch regressions and quality issues before they reach production, meaning before they reach real users. This is especially valuable as systems grow more complex and the surface area of unexpected failure grows. And third, and most importantly, especially for agentic AI systems specifically, is that evals are essential for building trust. So when an AI agent's outputs don't only generate text, but trigger real-world actions, could it be sending an email, executing a transaction, etc., the stakes of failure are higher. We cannot rely on a human reviewing every output before it has consequences. So the evals are the mechanism by which we establish that the system is safe to trust at the level of autonomy that we need. So we want these agentic systems to be reliable and auditable so that they can be scalable. Because if you have an unauditable system, it does not scale. So what is the difference between offline versus online? We can think of evals as these two complementary systems working together. Offline evals are our development quality gates. So imagine that you sort of have a lab environment where you can run fast and reproducible tests before anything ships. Every time a developer modifies the AI system, be it the model, the prompts, the infrastructure, these evals will run automatically to catch regressions before they reach a single user. But what works in the lab, as we know, is only a simulation of the real world. So that's why we need online evals. So these are sort of our radar, continuously monitoring live traffic in production to surface things that a static test suite cannot, such as novel user behaviors, unexpected input combinations, maybe gradual distribution shifts where the real world diverges from our assumptions. So together, offline evals give us confidence to ship, and online evals give us the signal to know what to test next. So the golden evaluation dataset is a very important asset in our quality infrastructure. It's a curated, structured collection of inputs paired with ideal outputs, spanning three categories. So you want to have in it happy paths, which are the common cases that the system must always get right. You also want to cover edge cases, the unusual inputs that may reveal brittleness, and also known failure modes, specific ways that we have seen the system break before. So we want to shift sort of our mental model to treat this data as code, meaning it's not just authored once, it's maintained, we can add to it, it's reviewed, it's versioned. So which brings us to a common mistake, to treat the golden dataset as a one-time artifact. Actually, as the product evolves with new features and so on, a static dataset will become stale. It will measure the wrong things and we won't notice it until something breaks in production. This is why we need to grow this golden dataset continuously by adding real failures discovered in production to keep it current. So we talked about how we can scale our evaluation. So at development scale, human review is very feasible, but in production, it's not scalable to evaluate possibly thousands of interactions per day. This is why we use a separate LLM as a judge to score outputs against our rubrics. It's about making the human judgment scalable. So humans define the rubrics and then calibrate the judge and audit its decisions. An LLM judge is only valuable if it's aligned with how a human evaluator would score the same output. I'll also add that it's not any human. It has to be a human who is subject matter expert in that domain that you care about. So we don't assume this alignment, we measure it by comparing with the annotations performed by these subject matter experts. We can use things like inter-rater agreement or Cohen's-Kappa to compare the judges' scores against the human-labeled samples. We also actively monitor for non-judge failure modes, like tendency to favor longer responses regardless of quality. That's called verbosity bias. Or the fact that they prefer its own outputs over others, self-preference bias. So the bottom line is if you have an uncalibrated judge, it doesn't scale quality, it'll scale errors. So this is a continuous improvement, not a one-time setup. So we've talked a little bit about the rubrics. How the LLM judge works is by using rubrics. What are rubrics? We want these rubrics to contain explicit criteria that decompose the quality into distinct, independently scorable dimensions, such as factual accuracy, tone appropriateness, instruction following, conciseness, and so on, rather than getting a single opaque score that says something fails, but we don't know what. This creates a shared quality bar that the team members, including subject matter experts, can reason about. When we use these rubrics, another thing that we can do is define anchors. So rubrics define what to measure. Anchors define how to calibrate the scale. For each rubric, we can provide the LLM judge with 2 to 5 labeled examples covering the quality spectrum from good to bad examples. And these anchors can help resolve ambiguity. It's recommended to also rotate these anchors periodically so that to prevent the judge from overfitting. So when an evaluation fails, of course, the instinct is to fix the immediate problem, patch the prompt or something like that. We need to deliberately not do that. Otherwise, it leads to playing a game of whack-a-mole, trying to change the prompt here and then it messes something over there. So we need to remember that a single failure is only a data point. Only if you have a cluster of failures, what we call a failure mode. So that's why we perform this failure mode analysis, which is the process of categorizing these failures systematically into these modes, such as, could be hallucinations, tool misuse, instruction ambiguity, things like that, format errors, context loss, and so on. Then we look at which categories account for the most failures. That way, we can use that to prioritize the most promising interventions, so we're not fighting fires reactively, but proactively and systematically engineering a better system. By the way, not all the failures will have the same fix. Hallucination may require fine-tuning or retrieval improvements, whereas a format violation could be resolved with one-line prompt change. A tool misuse patterns may indicate a deeper infrastructure problem with how the context is being passed. So it's important to diagnose these failure modes correctly so that we can come up with the right intervention. Putting it all together. So we talked about establishing golden evaluation set, how we want to calibrate the LLM judge. implement these offline quality gates, and monitor via the online radar, perform systematic failure analysis. And these core components don't exist in a vacuum. They form a continuous cycle of observation and refinement. By moving from these isolated tests to a connected system, we can shift from reactive patching to proactive quality engineering. And this kind of leads us to the ultimate goal, which is the production flywheel. So like we said, everything we talked about, the golden data set, the LLM judge, the rubrics, the failure mode analysis converges towards this production flywheel. When considered in isolation, each of these pieces can improve quality incrementally. But when you consider them together, meaning we log real interactions, right? Through online monitoring, we can observe where the failures are. We can perform this failure mode analysis and then feed the most important ones back into our golden data set and rubrics. This means the next evaluation cycle is more comprehensive than the last. So we're not just good at catching the failures today, but we're better at catching failures faster. And that acceleration is where the quality compounds. So if you have better data, you will have better evals and then better agents. That's basically it to the end. So thank you all for your attention.